engineer from Packet, which basically just means that I do things, but that's what's on my business card, so I figured I'd put it on the slide. I'm here to talk to you about the full Arm IoT stack that my colleague David and I built. This was basically a proof of concept, and we have a lot of friends that we want to thank for making this. The goal was to make a complete IoT platform, everything from the sensors all the way up to the cloud storage, entirely operating on Arm hardware with Arm software. And so want to thank Packet and the Works on Arm project, which is part of what I work on, Lenaro and 96 boards. We used Arm Mbed, miniNodes, and the Arm Innovator program helped pay for all of this. So how did we get here? And the answer to that was at TechCon 2 years ago. Simon stood up and said that you can do all of this on Arm. And we went, cool, but who is? And so we decided to sit down and actually build it. So 3 different pieces of the stack. One of them is the IoT endpoints based on Raspberry Pis, little things like this that we picked up with some SparkFun sensors on it. We're running Arm Mbed Linux OS on top of it. We have, in the deployed versions, we have air quality sensors, lightning detection sensors, and GPS sensors. And that feeds all the data to our edge nodes. Our edge nodes are 96 boards, Hikey 970 systems. So relatively straightforward. Our definition of edge, because everybody has their own definition of edge, is basically you have unreliable connectivity, but reasonable temperature and control. So we basically have them at some friends' houses. But you can access them from the internet, which is important. They're running a MQTT server, which collects all the data from the endpoints and then translates it into an influx query that goes to the cloud server running at Packet, so we can put all this on a lovely dashboard. So this is what the endpoints look like when they're actually in their deployed configuration, sans one wire. The lightning sensors are weird. It's all off-the-shelf parts. Part of the reason why we picked a Raspberry Pi as opposed to something else was simply so that we could keep the cost of running all of this down because, as we all know, they're $35. And the amount of stuff you can do with them is kind of fantastic. It also opened up the entire ecosystem of hats and sensors that were available to us through SparkFun, Adafruit, fun stuff like that. There are other sensors that we can use. I'll get into why we picked these here in a moment. We managed all of it with Mbed Linux OS, managed through Pelion device management from Arm. Works fairly well for managing the stuff on and off. We had a couple of issues. We'll talk about that in a minute. If you've never seen Pelion, it looks like this. So there are a whole bunch of our Raspberry Pis, some of which were plugged in at the time, some of which were not. And we sent them to everyone we knew all over the world. So all of the ones with little Raspberry Pis on them, that's where we sent a sensor to. The green ones are where we sent edge nodes to. So we have one edge node in Arizona, and the other edge node is in India. That posed some interesting challenges. And then the red dot is the actual cloud server that we're hosting at Packet in our Newark data center. This is the data we're currently collecting. So temperature, humidity, barometric pressure, total organic volatile compounds, the equivalent CO2 from that, and the location of the device. But you don't have to use these sensors. These speak over I2C, plugs into the SparkFun Quick Connector. There is a bunch of other sensors that you have available, infrared light, UV, human presence detection. This is all stuff that is available right now from SparkFun. You could basically plug anything that speaks I2C into it. And the reason why we picked these was because as we were starting this project, we were like, OK, what are some use cases that we could solve for? And everybody understands the weather. So we figured we'd start talking about the weather. But why do we want to talk about the weather? And the answer to that is because I live in Austin, Texas. My friend David, he lives in Phoenix, Arizona. And there are 2 common problems that we have in the Southwest, which also affect up here as well, and was talked about in the keynote this morning. Wildfires. So this is a big deal. And in fact, these are some examples of wildfires in Arizona. That big one on the side was actually across the street from my friend David's house. So this is before and after photos from his front porch. This particular fire was caused by, there is a model airport down the street from where he lives. Someone took off, crashed their plane unceremoniously, and caught all of the scrub on fire because model airplanes have fuel and stuff in them, just like real airplanes. It's kind of amazing. It burned something like 1,000 acres before they were actually able to get it all extinguished. It was kind of a big deal. No major property damage, just a lot of stuff out in the middle of nowhere, which worked out. But it was really close to some populated areas, and that got us thinking, what if we could build sensors to detect things like this that were out in the field? And that brings us to why we picked the sensors that we did. So the idea was we could actually look for lightning detection, which is a far more common way that some of these fires begin in the desert, is via lightning strikes. And then air quality so that we could see temperature, we could see if there's any volatile organic compounds in the atmosphere, get an idea of CO2, bring all of that data back along with where it was so that we can go from there. So that was the goal. David pinged me about this on our weekly Works on ARM call and said, hey, I'd love to do this. And I foolishly said, sure, this sounds incredibly easy. We'll have this done in 4 or 5 days. Here we are 7 months later, and not everything is working. So what we have done is we actually have the sensors on the machines collecting data. We wound up having to write all of that stuff in Python. We're using, like I said before, we are using Mbed. If we were to do this again, we would probably not use Mbed Linux OS. The process of writing code for Mbed Linux OS is interesting. Most of the documentation is specifically for C. We wanted to do our stuff in Python because there were readily available libraries for all the sensors that we were using. So we started working on that process. Mbed Linux OS supports containers. It's still in beta. It's pre-release. There's not a lot of documentation. We found every edge case, which slowed us down, but that's OK. So we are getting all of that data. It's being sent via MQTT to our edge nodes. We don't currently have the lightning detector working, and the total organic compound and CO2 sensors apparently have some sort of magical init string that we need to pass to them, and that's not working. But not really a big deal. The edge nodes and the cloud server, pretty much everything is up and running. The only downside is it's not as pretty as we would like. We had high hopes for being able to actually show, have a time scrubber down at the bottom of the Grafana dashboard where you could actually move back and forth on time, see storm fronts move through, try and get that data from Mapbox or something like that. We just ran out of time trying to get everything else up and running. It was a lot of effort. It was a great vision, but we have some numbers at least. But there's some stuff that we've learned, a lot that we learned on this project. And this is mostly what we wanted to share with people. This isn't so much a product. This was more a technology demo to see whether or not it could be done. So some of the things that we learned a lot about Mbed Linux OS. For some people, it's very different than your kind of normal Linux distribution. It's based on Yocto. It's very embedded focused. Getting the containers running on it is interesting. It's not your typical Docker environment. It's using runc. We also had a lot of interesting issues around certificates. So you remember the map where we had sent out all of those devices to. We got the devices up and running. We made sure they worked. And then we went and shipped them out all over the world. And about 2 weeks later, they all stopped working. We couldn't figure out why. And it turns out that they had developer certificates on them, and they expire after 3 months. Oops. Not a great way to upgrade that for the devices in the field, which is unfortunate. But the good news is we were able to find this, point it out in the documentation, talk to the Mbed and the Pelion team, and try and come up with a way to deal with this. Ironically, the response when we told them the problem that we were having with the 90-day certs was, oh, just put 10-year certs on it, it's fine. And we're like, except that's like illegal in 3 countries in Europe and several other places, so maybe we shouldn't do that. So we're working through it. It's not really a big deal. The other part that was entertaining is Mbed Linux didn't have support for I2C out of the box. This isn't a malicious thing. It was simply an oversight. How the distribution was built was by taking the kernel from Raspbian. And by default, if you don't know how the internals of a Raspberry Pi works, By default, all of the I2C, SPI, all the interface devices are turned off, and they have to be turned on with a device tree overlay. None of the features to support that were in Mbed Linux OS. So we spent some time wedging all of that in from Raspbian, but did finally get it working. Talked to the Mbed Linux OS team. They were super grateful that we were able to find that for them. Like I said, a lot of this is in beta, so this is in no way saying that you should not use this product. It is more just that we were early adopters. In fact, on one of the phone calls, everybody was like, wait, you figured out how to make all of this work? Because we haven't yet. So that was cool. We had the certificate issues. And then the other part that was entertaining, you may recall I said, we did all of this on ARM. We even did all of the development on ARM notebooks, which led to a rather hysterical bug in that no one had ever tried using the development tools from an ARM workstation before. So we went and installed the tools. We couldn't download them from ARM's website in ARM format. They were only available in x86. That was kind of funny to begin with. But the next part was even better, because we were just like, that's fine, we'll compile them from source. We're building them from source, and all the source builds failed, because it's like, I'm looking at this, and the target architecture is ARM. I've cross-compiled this for ARM, but it matches the host infrastructure, because no one had ever tried building it on ARM before, and it assumed that you were always building on x86. So it thought it was failing to cross-compile, even though the target architecture was the same as the host architecture. It was weird. But we got through it. We got everything working. We discovered that running some of this stuff on Windows Subsystem for Linux 1, not really the best idea. But running it on a second Raspberry Pi or on an Odroid worked out much better. So with that all said, this is what it currently looks like. So this is some snapshots that I took a couple days ago. You will notice that Mexico has no data points, and that's just because the post office is slow. It's not their fault entirely. We were late in shipping it out, but we had a friend in Mexico who we were hoping to get the machine to. The green line is temperature in degrees Fahrenheit, so no, our garages are not on fire. And the yellow line is the humidity. This one up here, Arizona 2, is actually David's laundry room, so you can tell when the dryer's running. That's why the humidity kind of bounces all over the place. And then we also have air pressure data, which is very interesting. You can definitely see that the storefront was pulling into Austin, Texas as it was leaving Arizona. And at the same time, David's laundry room is kind of a mess, but that's fine. Last thing is most of this was built with Windows on ARM-powered laptops. Everything that we did is open source. So there is going to be a blog post available on the ARM Innovator blog in a couple of days. So you're welcome to go download anything that we've done. You can ask myself or David questions. Our contact information will be in the blog post. You can also find my contact information for the program. Thank you so much for coming. I appreciate it.